Hello, everybody. We're just going to take a few more minutes and let a couple more folks pop on to the meeting, and we'll get started very shortly. We're going to get started in just one more minute. Thank you for your patience. Good evening, everybody, and thank you for waiting. More people as they join in, we'll get them on board as well. So good evening. My name is Karen LeBlanc. I'm here on behalf of the DDOT team working with the District Department of Transportation on the Canal Road Northwest Slope Stabilization Project. And thank you all for being here this evening. We appreciate it. I'm joined tonight by the project team. We have Zara Doritz, who is DDOT's Team 2 Program Manager, Tess Philem Aim, DDOT's Project Manager for this project, Yvonne Thelwell, Supervisory Civil Engineer for Team 2. I believe we've been joined by Alberta Paul, DDOT's Communication Specialist. And then the consultant is Gannett Fleming, and with us tonight are Tim Connor, Senior Program Manager, and Matthew Morris, Vice President and the Geotechnical Practice Leader. Before we start the presentation, I do have a couple of housekeeping items. There will be a Title VI survey at the end. You will receive an email following the meeting asking you to fill out that survey. It is important for our record keeping, so we do ask you to fill out the survey. It's very quick, it won't take very long at all. And just hit submit and we'll receive that back on our end. It would be very much appreciated. Also, during the evening, you may have some questions. You can certainly post that in the chat, or you can post your question on the Q&A button, which is down on the bottom right-hand side of the screen. I will be answering at the end of the presentation questions in the order that I see them on my screen. Anything that we don't get to this evening, we will certainly be following up with people after this evening's meeting. We do want to advise you the meeting is being recorded and is currently on DDOT's Facebook Live channel. A recording of the meeting will be immediately available on Facebook and also posted to YouTube in the next few days. And now I would invite Mr. Aim to begin the presentation with some background and general information. Tess?
Thank you, Karen. Good evening, everyone. Myself and my colleagues will be presenting to you project background, project overview, and the status of design for Canal Road rock slope stabilization. As you can see on the picture, please the first slide, Karen. Yeah, as you can see in the picture, rockfall and landslide incidents occurred on Canal Road Northwest a couple of times. And this incident is of rockfall occurred on Canal Road Northwest near Clark Place intersection. Such incidents are safety hazard to motorists, and they can cause property loss, personal injury, or even loss of life. On top of that, on this particular section of Canal Road, we have very limited right-of-way, about 23 feet, that can accommodate only 2 lanes, 1 lane on each direction. So whenever a rock fall incidents occur, it will close 1 lane, and that means the westbound traffic will be closed, and traffic will be forced to detour or divert to Foxhall Road through MacArthur Boulevard. And such incidents of rockfall will create congestion on those arterial and collector and local roads. On top of that, when we have such incidents, the need for emergency maintenance, and if such incidents occur in rainy day, which usually occur because pressure build up in the fractured rocks due to rainwater and can cause rockfall, and when that happens, and falls on storm drainage system catch basins, it can block the inlets and probably can lead to flooding. So all in all, rockfall and landslide incidents create unsafe streets. Next slide, please. As you can see, even here, those rockfalls is a hazard to commuters who use Canal Road Northwest. DDOT is committed to improving transportation safety and creating safe streets. And this incident initiated the geotechnical study of Canal Road Northwest. And the preliminary study assessed potential rockfall hazard areas and recommended a mitigation measure. Based on this recommendation, DDOT embarked on this project to stabilize the slope and mitigate the safety hazard and safety concern along this section of Canal Road Northwest. This section, next slide, please. So this section of Canal Road, as you see, this is Canal Road Northwest, and this is Clark Place Northwest. So this is the intersection of Clark Place Northwest. So our project extends about 1,000 feet eastward from this Clark Place intersection, and for about 400 feet west of Clark Place intersection, and about 320 into Clark Place Northwest. So this is our project limit. This is the area that the geotechnical study has identified as an area of potential rockfall and recommended a remedial action. The incident that I showed you in previous picture was incident occurred here. So this potential rockfall is a risk and a hazard, safety hazard to commuters who use Canal Road Northwest from DC, from Maryland, and from Virginia. So my colleague team will present to you the project overview and where we are. Please, team, proceed.
Thank you, Tess. So as Tess mentioned, the project began back in 2014 with an earlier geotechnical study. This project has two very important goals. One being to find a mediation or a mitigation measure to address the slope failure issues, as well as considering what the costs and impacts are to the public. And again, as Tess mentioned, with a slope failure, the road, it's it becomes a large impact. So we began our project back in September of 2020. We are currently in the design phase of it, moving towards 90% design submittal. We're looking to have the design and project ready for advertisement by the end of this year, hopefully early or mid-December. After that, the project will go into advertisement, and once a contractor is selected, there will be another public meeting prior to construction to bring the contractor on board and allow them to present how they're going to proceed and construct the project. We have several key stakeholders within the project area here. Most of the property along the slope is owned by and maintained by the National Park Service. The District of Columbia, obviously DDOT is a contributing stakeholder here. They are actually procuring the slope project, stabilization project, and they will also be ensuring the work zone traffic flow during construction is maintained. Property owners, again, with this project being not only in a commuter corridor, but also adjacent to residential properties, these owners are major stakeholders here. There will be slight impacts to not only the walking trail, but with some construction noise, and the construction detours will obviously impact traffic for a short period. Matt, I'll turn it over to you to talk about some of the alternatives we've looked at.
Okay. Thank you, Tim. I'm going to basically walk through 3 alternatives that were considered. All of these alternatives have one common thing in common, is that they prevent rocks or landslide debris from reaching Canal Road and creating the impacts that Tess mentioned before of road closures, public safety hazards to the drivers down there, as well as impacts to the stormwater management system at the toe of the slope. So these are basically grouped into, as I said, 3 alternatives. The anchored wire mesh is a reinforcement measure, and reinforcement measures actively stabilize the slope and also prevent the rockfall from reaching Canal Road. Whereas alternatives 2 and 3, a slope drape or a rockfall barrier, are considered protection measures in that they protect Canal Road from rockfall or landslide debris coming down onto the road. However, they do not actively stabilize the slope between the road and the top of the slope, the trail at the top of the slope. So I'm going to take a few minutes and walk through each of the alternatives to explain them, discuss basically give a description of them, provide some pictures and schematics so that everyone can understand what we looked at here, and then we'll move into the selected alternative and discuss that. Slide, Tim. Okay, slope stabilization alternative 1 is an anchored wire mesh system. Now you can see in the pictures on the right basically what this consists of. That goes, if you follow those photos top to bottom, that is an unstable slope where the soil and rock had been sloughing off. The second picture down shows kind of you can see a grayish, that's a high tensile strength wire mesh that gets installed on the slope and pinned down with rock anchors. And then the third picture down is the completed project with vegetation coming back through. Now, As I said, this is an active system in that we are stabilizing the slope as well as preventing the debris from coming onto the road. It does require removal of trees and brush from the slope. Larger trees, select trees, high value trees can be kept, and the mesh can be positioned around those. And ultimately, the rock and debris that wants to fall down is held in place by this anchored mesh system. The installation of the system requires closure of that slope side lane so that those anchors can be drilled, the mesh can be placed, the clearing can be done, and loose rock can be removed from the slope during construction. But all of the activities can be facilitated from within the District of Columbia right away, and both at the toe of the slope and the top of the slope, and on the National Park Service property, the slope proper. So, Tim, you want to slide on to the next one? So this is a schematic, and the image on the left side of your screen is a cross section looking east along Canal Road. Canal Road is the flat area at the bottom of the image, and the trail is the flatter area at the top of the image. And basically, you can see that there's around 55 feet of vertical exposure that comprises the slope face, and it's a mixture of soil and rock and weathered rock. And the anchored mesh system would be installed from the flat area at the top, basically the crown of the slope, the entire way down to the toe of the slope, just a few feet above the roadway surface itself. And it's anchored down with large steel anchors that are grouted into holes. And these are basically 10 to 20 foot long anchors. And they anchor the mesh down and hold everything in place. Think of it kind of like a pin cushion effect of holding this mesh down and trapping everything behind it. Next slide, Tim. Okay, slope stabilization alternative 2 is a wire mesh slope drape. And again, this is a protective measure in that it controls the rock and soil that wants to fall off of the slope and traps it underneath there while it's falling and slows it down and deposits it at the toe of the slope. At the bottom of the slope, we would need a concrete barrier to retain this material so it still didn't spill out into the road, and it would require regular maintenance to keep that area clean. And so you didn't have debris piling up in certain areas behind the barrier. It also requires removal of trees and brush from the slope. There is the potential, if you had a major rockfall event, that this mesh could be damaged and would require repair. Again, it would require closure of that slope side westbound lane during construction activities. And the anchors for this would be drilled along the top of the slope, along the trail, similar to the anchored mesh, where it would basically anchor from that edge of the slope down to the toe of the slope. Go ahead, Tim. Again, here's the schematic on the left of a similar section that I showed before, that cross section showing where the mesh would start at the top and extend down to the toe of the slope. The concrete barrier is shown there just above the 21+00 indicator. Again, in that schematic on the right essentially shows how the mesh works and that it controls rockfall coming down, and then it falls into that quote run out zone at the bottom. Since we don't have a ditch like that, that's the reason that the barrier would be in place, is to help control that material and keep it there until it can be cleaned out, but preventing it from reaching the road. Next slide, Tim. Stabilization alternative 3 that was considered was a rockfall barrier, and the image on the right shows a barrier along a roadway in central Pennsylvania in the mountains. Basically, this is a steel barrier that's constructed between the toe of the slope and the roadway itself. And you would need a concrete barrier or a guide rail in front of this to prevent any traffic from hitting it should they come off the road at all. This one's unique in that it doesn't require any construction on the slope face or top of the slope at all. It would, however, require regular maintenance and cleaning of debris from behind the barrier. and potentially major repairs following a major rockfall event would need to occur there. Again, you would still be closing that slope side or westbound lane of Canal Road during the construction activity so that this could be constructed, drainage improvements could be made, and ultimately the concrete barrier or guide rail could be placed in front of it. Slide. So this is how that barrier would be positioned at the toe of the slope. You can see there's nothing on the slope itself here. The barrier would be anchored down at the toe behind a concrete barrier. And basically the image on the right is an oblique image of what this would look like. And basically what happens is you install a series of posts on about a 25 to 30 foot spacing along the toe of the slope. You put up some very high strength wire mesh along those posts with some cables, and any blocks that come down and impact that are trapped behind the barrier. So next slide. Okay, so we considered these three different alternatives. We discussed with DDOT and the National Park Service all of the alternatives that we considered, the pros and cons of each, the aesthetics of each, and kind of the finished product and what provides the best solution. And the anchored wire mesh alternative number one was the selected alternate to move forward in design. Really the biggest advantages are that is from a cost benefit solution, it provides the most. It stabilizes the slope in place and prevents rock from coming down the slope. And when we talk about stabilizing the slope in place, why that's important is that as landslides continue to occur and as rockfall occurs, the top portion of the slope continues to get undermined. And as that's undermined, we start to lose real estate, that flat area at the top for recreational purposes, the trail, if you will. This system is generally maintenance free, meaning that the DDOT nor the Park Service needs to come along the toe of the slope following an event and clean it out, as would be with the slope drape or the fence, rockfall barrier fence. It is aesthetically pleasing. Basically, once it's been installed, you won't see it because it'll grow vegetation back through it, and I'll show some examples of that. It can be powder coated to match the surrounding rock. This image on the right is of one that was installed next to a industrial area, office complexes, things like that, that was having rockfall issues. Then this is about 3 years after construction, and we were starting to get vegetative growth back onto even the areas that weren't seeded. The natural rock surfaces were starting to revegetate themselves. So it does attract vegetation growth, it does attract vine growth, but it does prevent larger trees from coming through that mesh. It's a very high tensile steel mesh, not like, don't think chain link fencing. It looks like it, but it's much higher strength than that. So next slide. So the construction process behind installing something like this, and this is this photograph that you're seeing is a slope also in Pennsylvania that was done. This is back in, I think, 2006, this was built. And basically a similar situation. You have a 2-lane roadway with lots of rockfall issues. You can see the overhangs there. The rock bolts were installed. Basically, the way that the process works is you remove the vegetation and you get rid of all of the loose rock blocks that are kind of precariously on the slope after the vegetation's been removed. Then you install the rock anchor dowels. And Tim, can you highlight one of those dowels? Yeah, that's a picture of one of the dowels right there. And you can see those throughout the image at different places on the slope. There's a pattern to them, typically around a 12-foot to 15-foot horizontal and vertical spacing. So those dowels are drilled in. You drill a hole, you insert a steel bar, and you fill it with cement grout. Then you place seed and turf reinforcement mat on the flatter portions of the slope. So in that image, at the crown of the slope, you can see some pretty green vegetation growing up there already immediately after construction. That seeding that's done, it will be done with native seed material per the National Park Service request. So really what we're trying to do there is keep invasive species from growing on the slope and try to keep as much natural vegetation, grasses on that slope as possible. And then finally, after the seeding's done and that turf reinforcement mat is placed, the wire mesh is placed over top of the rock and the turf reinforcement mat and everything, and over top of those dowels that have been installed. And then that diamond-shaped spike plate is installed on top and attached with it basically works like a washer and a nut. There's a very large nut, gets put on, it gets torqued down, and essentially pulls the mesh down tight to the slope face, creating that pin cushion effect, which doesn't allow material to, if it does become loosened on the slope face, it's just held in place at that point and not traveling down the slope to the road. Next slide, Tim. And this is that same slope, same exact place in the slope, a few years after construction, and you can see the vegetation growing on the slope, a little bit of the mesh exposed in the steepest areas there where the rock was exposed, but even the areas that didn't have seeding or vegetation mat on them have really revegetated completely at this point. And the rockfall mitigation is working fine. We're not getting rockfall coming down there, and the toe of the slope is vegetated as well there. Next slide. I think I'm turning it back over to Tim to discuss drainage along the toe of the slope.
Thanks. Yep, thank you. So as part of the improvements to this area of Canal Road, we are installing an upgraded drainage system that will not only address some of the water actually coming down from Potomac Avenue over the slope here, but also some of the ponding and water issues that are currently experienced along Canal Road. So the first item here is we are tying into an existing inlet at the top of the slope that will have a pipe coming down the slope into a new inlet. This ties into the existing drainage system to the west of Clark Place. We're also installing new inlets within the area and pipe connections. On the east side of Clark Place, we're installing a new system that again will tie into the existing system as you go down towards the Foxhall MacArthur Boulevard intersection. Again, new inlets, new pipes to address some of the low point ponding areas that are currently, on Canal Road. So obviously with this type of construction, as you can see from the picture here on the right, there is going to be heavy equipment. While Matt did mention that some of the work can be done at the top of this slope, there will be the need to close a lane on Canal Road. So the impacts here are really to the Palisades area, as well as people coming out of Georgetown or going into Georgetown that will experience some of the traffic problems with the lane closure on Canal Road. So currently we are in the process of looking at how this project is going to impact traffic flow. As mentioned, we're looking at a single lane detour. We're going to try and keep one lane open, which would be along the canal side of the road. The detour here would follow the peak direction traffic, utilizing MacArthur Boulevard through through Foxhall, up to the Arizona intersection, coming down Arizona back and returning to Canal Road. The alternate to that is the George Washington Parkway. After several days of sitting in traffic, things will even out and people will divert, likely either to the George Washington Parkway or to other roadways, and also utilizing the designated detour. We're currently in the process, like I mentioned, of developing a traffic management plan. We're closely coordinating that with DDOT traffic. We're looking at the key intersections along the detour route. There is limited alternatives here with the location of this project. So the detour right now seems to be the preferred or the more likely alternative, but we are exploring other options, and depending on how the impacts to various intersections go, will determine what the best alternative is. But again, that will be closely coordinated as we get closer and closer to determining the construction here. So this just shows right now our plan for the peak hour detour. As I mentioned, the slope side travel lane here would be closed for the duration of the project, which right now we're anticipating about a 6-month duration. The canal side lane would remain open, again, in the peak hour direction, depending on time of day. We're looking at just the two directional flow during construction. We would not allow two-way as is allowed right now during middle of the day or overnight. We'd want to keep it in a single direction. The actual time of day right now we have from 12 midnight to 12 noon. However, again, depending on the traffic flows and how the overall traffic needs are, those times could change, but they will be directional, I guess, is the main focus here. And that is the end of our information on the design. Karen?
Thank you, Matt and Tim and Tess. That was all great information, and thank you all for presenting it. So as you heard, we will be returning for another meeting to the public once much of the traffic control plan is drafted, again, to receive your feedback and public input. I would ask again if you could remember to fill in the survey that will be sent to you following the presentation. That would be really great, and appreciate everyone's time this evening. And now we will open the floor for any questions. If you do have a question, you can either put it in the Q&A or just raise your hand and we'll be able to see that, and we will call out on you. No questions at all? Molly, do you see any questions? I just want to make sure I'm not missing anything, or that there's anything in the Q&A.
No, there are no questions in the Q&A. A hand was up briefly, but it went down. Oh, I think a question just came in.
I don't see it on my list.
The question is, will Clark Place be able to access Canal Road?
I'll take that one. So right now, yes, Clark Place will be able to access Canal Road with the exception of the time period that construction at that intersection is actually going on. So there would be a brief closure of Clark Place during that time frame.
You're welcome. Are there any other questions?
John Wells has raised their hand.
You want to unmute them, please?
Yes.
Mr. Wells?
I'm not used to this WebEx software, so I was having a really hard time figuring out how I can't even see my picture anywhere. I'm used to Zoom and sometimes Google Meetings and all this competing software. It's hard to keep track of all the different how it all works. So I am with Palisades Community Association and also the ANC 3D Transportation Committee. And we have taken a particular interest in Canal Road. And I want to say we're delighted that you guys have done this serious analysis of slope stabilization. So I guess, I got on a little to the talk a little late because 6:30 is not an optimal time for me. So maybe you talked about this at the beginning and I missed it. But could you tell me a little bit about where this project fits into the broader set of proposals that were made by DDOT in its report back in 2016, I think it was, which involved a lot of different proposals to improve traffic flow and safety along Canal Road. Is the slope stabilization project sort of a one-off, or is it intended as the first in a series of projects to improve safety and excuse me, safety and traffic flow along Canal Road? If it's part of a series, can you tell me anything about what the status of the of looking at the other proposals in that report from 5 or 6 years ago, and how far your thinking has gotten in terms of carrying out those other proposals?
I can feel this one. Yes, I am familiar with the prior report. This project, though, really just deals with stabilizing the slope and correcting some of the drainage issues just along the area. It's like about a 1,400 linear foot section around Clark Place. It does not going to address any other issues that were brought up in that report. We are, though, continuing to look at the report. I did see a letter, I guess, that the ANC had written recently, kind of asking about some of the safety concerns, and that is still being looked at, but that is under a different, entirely different project.
Okay, so
Does that answer?
So
Yes.
this the slope stabilization project then is basically a one-off, and tell me a little bit more about how it's being addressed organizationally within the DC government. I assume DDOT is an important player. Does it involve other agencies within the DC government?
Well, it really, the slope itself is actually on NPS property.
Right.
The slope is not on DDOT property, but since it is a safety concern to Canal Road, which is part of our network, we have taken upon ourselves, and we are working with NPS to actually stabilize the slope and fix the drainage.
Right. So it's a joint DDOT NPS project then?
Correct.
Yeah.
Correct. And if you want to see the limits, Tim, maybe you can go back to an earlier slide that actually shows the limits of the projects, and we can show him since that was early on, he may have missed. So here you can see the actual limits of this particular project. So it really just pertain to the slope and then the drainage at the toe and along Potomac.
Okay, so it's really only that portion near Clark Place.
Correct.
Yeah. And can you tell me more about the considerations that led you to focus just on that portion of Canal Road and not other parts of Canal Road?
Sure. Well, there were is the rock slides actually where debris actually landed into the roadway, so it was a safety hazard, not to address it immediately.
Yeah, to add
They would
to
actually had
it,
a lane closed for periods of time to clear the debris and make sure that it was stable enough to carry on.
yeah, the previous geotechnical study has some drill test holes all along the Canal Road. It's not all, but in some visually suspected and in the areas where there was a previous incidents. So the outcome from that geotechnical study was this area west of Clark intersection, Clark Northwest intersection in east is the one which has a potential of rockfall. We have mentioned at the beginning, like it is 1,000, about 1,000 feet east of Clark Place Northwest intersection and about 400 west of this intersection. So this is as a result of the geotechnical study that includes drilling test holes and investigating the potential of rockfall.
Mm-hmm. Right. And
Obviously, we cannot do the drilling all along the Canal Road because of obviously limited resources. The study was focused on visual and at the same time of previous incidents of rockfall.
right.
And we will address as further if such incidents occur. Definitely, DDOT is committed to making the streets safer.
Mm-hmm.
Yeah, sorry, I interrupted you.
Right. And are you anticipating analyzing other portions of Canal Road to do similar work on those portions?
As I said, currently there's ongoing discussion on another part of Canal Road Northwest, and it is entirely on the MPS land or right of way. So there is a legality issue into it, but definitely yes, we are all concerned and DDOT or staff and the management, and we are trying to find a way how we can implement further similar projects to make sure that the Canal Road Northwest is safe and commuters will not have this safety concerns.
Right, right. And are you looking for any particular feedback from the community on the proposed project?
Absolutely. When we have a new project, we'll go public about it in the development phase. But we already have some feedback regarding what occurred last year. So yes, any feedback would be welcomed, and we will go public whenever there's a development of a new project.
Uh-huh, yeah. I mean, my general feeling is that the community would be supportive of the project. Obviously, there would be some concerns about the closure of a lane on Canal Road and the spillover traffic down MacArthur Boulevard. But I think people recognize the importance of the project and would generally be supportive of it. So, and since I'm involved in both the Palisades Community Association and the ANC Transportation Committee, I'd be happy to try to orchestrate the community support for it. But mostly what's important to me is knowing sort of what your time frame is and when you need that community feedback to move forward with the project.
I do want to mention that, as mentioned, we are going to have, once we have actually put out to bid and have a contractor on board, we'll have a much better idea of the schedule and the detours and that sort of thing. And we would certainly reach out to you and maybe even come and present at the ANC meeting.
Right.
At that time, we would welcome that.
Right. Right. Okay. Good. And can I get a copy of the slides? And has this been recorded or not?
Yes,
Yes.
it is being recorded. It's going to be on Facebook, DDOT's Facebook page, probably within minutes of the end of the presentation. And then it'll also be on DDOT's YouTube channel within the next 24 hours or so.
Uh-huh. Okay.
The presentation will be on the webpage for the project.
Right. Right. Could you send me a link to the so that I can get the both the recording and the slides?
Yep, I will
Or if you
follow
want
up
to
with you.
send us your email address, or
Yeah,
else
I'll-
if you're on the
I'll put it in-
AMC, we'll be
I'll put it
sending
in
the
chat.
presentation to the AMC.
That'd be perfect. Mr. Wells, if you're done, I'm going to move on to another question, but I want
go
to make
ahead.
sure you're
Yeah.
okay. Angelique has a question, or Christoph.
Yeah, I see that one. This is Matt from Gannett. Yes, that's one of the things that we will be looking at. So the slope will be devegetated as part of the process, the construction process. And all of the seeding that is done out there will be using native plants, sustainable vines, in an effort to try to get rid of some of the more invasive species that have been out there. We'll be working with the Park Service to develop a good specification to try to eliminate what they don't want and put back the good native species that we want to see out there. So
That's great. Thank you.
Matt, do you want to mention, I'm not sure if you did, the trees that we are actually saving?
Yes, thanks, Tim. As part of the study, we went out with Janet Fleming, as well as DDOT and National Park Service arborists, and looked at the slope and basically identified, I think there were six trees out there that were either considered, high value species or heritage trees that will be remaining in place. The contractor will have to work around those during construction, and those trees will remain in place, both before, as they are now, and after construction is done. You're very welcome.
I muted myself there for a second. There was another question regarding the project limit slide, and I'm not sure who asked this, but why not extend the stabilization project the entire length of Potomac Avenue to maintain uniformity in vegetation and view on Potomac? It appears to be no more than an additional 50 feet.
I think we have added 100 feet on eastward from our current project limit because we identified a potential of rock fall. So basically the project is to stabilize the rock slope. It is with objectives to mitigate the hazard, safety hazard and safety concerns in this section of the road. So if there are other rock falls or potential rock falls, DDOT might consider, but basically every project is initiated with a budget and fund to accomplish its targeted purpose. So we will have to be limited to what we have proposed. But if there's potential or observed, like we have some reports which is under discussion to be considered. Obviously might not be included in this project as this project has advanced, but definitely it is the DDOT's way of handling projects by projects and mitigating any safety hazard. So the schedule and budget is also has its own procedures, as you. So definitely, if there is any rockfall incident or potential, DDOT will be considering.
I just want to kind of piggyback on that. Is I think if driving along Canal Road, it's pretty steep there. I'm not sure if you would really notice. I mean, from the aerial view, I think you can see Potomac Avenue very clearly where it ends. But I think if you're driving along Canal Road, I'm not sure if where the project ends or begins would be noticeable relationship to the end of Potomac Avenue. I don't know if I'm making myself clear. But when driving along Canal Road, where it ends, I don't think would be that noticeable whether or not it aligns with the end of Potomac Avenue.
So that's what Yvonne, in the Q&A, the person has responded, and I think that's what they were asking was not so much on Canal, but on Potomac. So it would be noticeable for people driving along Potomac on the upper part, looking over.
Okay. Again,
And they said thanks.
Yeah. Well, we'll take a look at that. I'll actually go along Potomac and kind of take a look because I don't know if looking. I mean, as the slide that they show, it does fill in pretty quickly. So the larger trees, as we mentioned, will retain, and then the vegetation does fill in fairly quickly. But we can take a look at that.
Okay, they said thanks. And then we have speak to trees. We do have two questions regarding trees. The first is, do you know what kind of new trees will be planted on the slope? And then secondly, if new trees will be planted, where on the hillside slope would they be and how tall?
Yeah, I can handle this one, Karen.
Thank you.
No, we would not be planting new trees on the slope. The wire mesh that's going to be in place will prevent large trees from growing on the slope. So what we plan to do is consult with the National Park Service and identify a good seed mixture that has native, basically low elevation growth seeds in it, mostly grasses and or native vines that would be planted on the slope. Large trees that grow large, we really couldn't do that because the anchored wire mesh will not allow them to grow through the mesh itself. There may be some, I guess, medium-sized trees, if you want to look at it that way, non-native species or native species that just happen to take hold, but active tree planting will not be done on the slope.
Okay, great. That is all the questions I see, both in the chat and in the Q&A. Okay, I think that's it. I don't believe we have any other further questions.
Judith has raised their hand.
I spoke too soon. Judith? Molly, if you'll unmute her, that'd be great. Judith, did you have a question?
Can you hear me?
Now we can, yes.
Yay. Will somebody be consulting with the people who actually live on Potomac Avenue? I mean, knock on our doors or give us information saying, hello, we're here. We want to talk to you about the slope and what's going to be planted there across from your house.
I guess I can speak to this a little bit. It's given it's the National Park Service's land. I don't know. I'm not sure about that. We are going to be working with them to plant what the Park Service wants to be put back there. But that's something, I guess that's a question for others to answer, and we can talk about it and provide an answer back to you, certainly. But that's the approach we're taking right now.
Like team has stated, is within MPS right of way, but definitely, if you have idea and opinion, you're more than welcome to email to us, and we'll consider that. We'll discuss that with MPS and let you know the outcome.
It does not seem to be an unreasonable request, given that, you know, we live here
Absolutely.
and we want our slope to be
Again-
healthy. We want our slope to be healthy, definitely. Are we? Okay, thank you.
Yeah, I'll just add one comment to that. Right now, it will be that native seed mixture that Matt spoke about. So it's not going to be a high vegetated slope, if you will. It'll be more, you know, again, over time, it'll be the vines, the small trees that'll grow between the wire mesh, but it will be a stabilized slope. Right now, I would envision, if you're looking out your door, you're seeing that almost grass area above, you know, on the other side of the rocks, if you will. That's probably what you will see at the end of this also.
Thanks.
Welcome. Anybody else have any questions this evening? Okay. Well, Tess, did you have anything you wanted to close with? Otherwise, we'll be back again in the community when the time comes to discuss the traffic control plan.
I would like to thank everybody for coming tonight. We really appreciate your attendance, and as we mentioned earlier, we certainly welcome your feedback. If you have any comments or think of any questions down the road, please feel free to get back in touch with us. As they mentioned, that this recording will be available on our Facebook page, and we will put a copy of the slides on the webpage within a couple of days. Thank you again.
Thank you. And if you
Thank
could
you.
remember to please, oh, sorry, Tess, to fill out the survey, that would be very helpful. Sorry, Tess, I didn't mean to cut you off. Thank you all again for attending. Have a good evening.
Thanks, everyone.